Assalamu alaikum everyone. This is me Shuhail, and in this video I am going to talk about the IC LM317. So first of all, the question is, what is LM317? Right, LM317. Simply, the LM317 is a voltage regulator IC. And what is a voltage regulator? We all know that the voltage regulator is a device which maintains the constant output voltage. Right. This IC also maintains the constant output voltage. That means you want the output voltage 5 volt. Okay, you can have the 5 volt, but uh, uh, you can have the output voltage 5 volt. This 5 volt won't change according with the change of the output resistance or with the change of input voltage. Okay, you are changing the input voltage or you are changing the output voltage, the 5 volt will be constant. So this is the characteristics of a voltage regulator. That means which voltage regulator maintains the constant output voltage, right? But the special characteristics of this IC is you can change the output voltage, okay, according to your need, right? You may have the IC like LM7805 or LM7809, or may you have LM7812. That means these are the output voltage rating of these ICs. That means this IC will maintain the 5 voltage output, this will maintain the 9 voltage output, this will maintain the 12 voltage output. This output voltage can be changed with the change of the output resistance or the input voltage. Okay, by any means you can change the output voltage, but if you use this LM317 you can change the output voltage. So you can say that it's also a variable voltage regulator. Okay, so first of all, you know, you have you must have the idea uh, of this IC, right? You have this picture. I have taken this thing randomly from the Google. So it has 3 pins. Okay, 1, 2, 3, and these are called, one is adjust pin, second one is voltage input, and third one is voltage output. Right. I don't know in which language these things are, but simply if I draw this thing again, then it has 3 pins like that. It has voltage input, voltage output, and this pin is used to adjust the output voltage according to your need. So how can we adjust the output voltage? This is the question now. Okay, so first of all you have to make the circuit like this. You have the 3 pins like this is voltage input and this is the voltage output, and the circuit should be made something like this. You know, you have to connect a resistor which we call limiting resistor, current limiting resistor, let's say R1, and you must have this variable resistor R2, okay, to adjust the output voltage, and these two drops will make the output voltage V out, or let's say VO. Okay, yeah, this is the circuit diagram of the circuit connection 3 by 7. So how can we get this output voltage V naught? Let's get the equation. So there will be a little current injected in this branch, let's say IADJ, adjustable current, and let's say this is the current I ref or IR, right? So V out will be what? The voltage drop across this resistor and the voltage drop across this resistor, and this is the variable resistor, you know. So we can write that V out is equal to, let's say voltage drop across this resistor is V1 and this resistor is V2. So V naught is equal to V1 plus V2. Okay, simple. So what is V1? V1 is equal to I1 multiplied with R1. And what is V2? V2 is the current flowing through this R2 resistor is IR plus I adjustable or IADJ. Okay, so the voltage drop across this resistor R2 will be I1 plus IADJ multiplied with the resistance value R2. Okay, so if we rearrange these things a little bit, then the things comes this. Okay, ATJ plus ATJ R2. Okay, so this I adjustable is in milliampere, right? So you may neglect this portion. Okay, you may have this portion only. So I1 R1 plus R2. That's it. Then what is I1? I1 is V1 divided by R1. Simple. V1 divided by R1. This. What is actually V1? V1 is actually the V reference. And what is V reference? V reference is actually the minimum voltage that then you can get from this IC. Okay, you can make V0 is equal to 0. You must have a minimum voltage from the output, which is called V reference, and the value of the V reference of this IC is 1.25 voltage. And I must say the current rating should be 1.5, around 1.5 ampere. Okay, you can't go much above of this rating 1.5 ampere, then the IC may be damaged. So you can say that V1 is V reference or V ref. Then I have the rest of the thing like like this R1 R2. Then if I multiply this portion with this portion, then the rest of the things comes V reference. That means this thing will be cut, and then yeah. Okay, so this is the output voltage equation for this IC LM317. So now this V reference is always constant, that means which is 1.25 voltage. Then we can have any other voltage by adjusting this R2 value, right? But the maximum voltage then we can attain, that means it's the rating for this IC, which is 30 voltage. Okay, so we may not supply more than 30 voltage to this IC. Okay, that is it for now. But I want to show you the practical scenario. That means I may not show you in the real life, but I can show you this thing in Proteus simulation. So let's move to the Proteus simulation software to see how this actually does work. Welcome to Proteus simulation software. Now in the screen we can see a circuit diagram. This is the circuit diagram exactly shown in the previous PDF section. We have the IC LM317, we have the current limiting resistor R1, and we have the variable resistor R2. In addition, we have the supply voltage V in 20 voltage, and we have the load resistance R2 to see if the output voltage changes with the change of this load resistor. Okay, so I am running the simulation now. Yeah, we can see that we have the input voltage 20 volt and we have 11.7 voltage at the output side. Now we change the load resistance and see if the output voltage changes. We can see I am changing the load resistance, but the output voltage is always same. That means this circuit is working as a voltage regulator. Okay, now you may have to change the output voltage. Okay, your project, your experiment may require a different value of this output voltage range. So how can you change this voltage? Then you have to touch this potentiometer. Okay, the value of the R2. Okay, You may recall that output voltage equation from the PDF, which I have already mentioned, that the output voltage depends only on this R2 value. So if you increase the R2 value, then the output voltage will increase. If you decrease the R2 value, then the output voltage will also decrease. So in this, now I may have to decrease this output voltage. So what I have to do, I also have to decrease the value of the R2 resistance. Okay, so I am decreasing, so yeah, I am decreasing the output resistance, and you can see that the output voltage is also decreasing. Okay, you can see I am lowering, and lowering, and at the lowest point I am making this resistance value 0, and I am having this 1.27 voltage. It is around 1.25. I have already told you that you may have the minimum voltage 1.25 voltage, or around 1.25, and if you increase this resistance value, you can increase this output voltage. Okay, this output voltage won't change with the change of the output load, you can see, or with the change of the input voltage. Okay, so this is it for this section. This is it for the video LM317 IC. So these types of circuit or device is very much important for your electronic project, for your Arduino project, or for your experiment, for your different kind of experiments. So if this video comes to your work, or if this video helps you, then please do like, share, and comment whatever comes in your mind. And yeah, please stay with me for these types of helpful videos. Okay, so bye, see you later.